Good morning. Last session we talked about the atomic structure of matter, and we said the matter consists of molecules, and these molecules consist of atom, and the atom is the fundamental building unit of matter which we can share in chemical reactions. This is called an atom, and we talked about the chemical symbols of some elements, and I said this symbol is very important, and we must know each element and each its symbol. After this, we talked about the structure of the atom, and we studied that the atom consists of two parts, nucleus and electrons. Nucleus present in the center of the central core of the atom, and the electrons revolve around this nucleus in fixed orbits called energy levels. And we talked about the nucleus has two particles, protons and neutrons. Protons positive charge and the neutron is a neutral charge. Neutral charge mean uncharged, and the electrons that revolve around the nucleus is negative charge. And we said that the nucleus the charge of the nucleus is positive. Why? Because nucleus has protons, positive charge, and neutral charged neutrons. And the electron negative charge, and there is an information is called that the number of electrons that revolve around the nucleus is equal to the number of protons that are present inside the nucleus. So the atom is neutral charge. Why? Because in ordinary state it's a neutral charge. Why? Because the number of positive charged protons that are present in the nucleus equals the number of negative charged electrons that revolve around the nucleus. And we talked about the mass, and I said that the mass of the atom is concentrated in the nucleus. Why? Because the mass of the electron is very small, that can be negligible relative to the proton and the neutron. So the mass of the nucleus concentrated, the mass of the atom concentrated in the nucleus. And we said there are two numbers to each element that be written at left side of the element. The first number is written above the element, and it is called the mass number, and it is the largest number. The second number is called atomic number, and it is written under the element. The mass number is the largest number. It is the sum of the number of protons and the neutrons in the nucleus of an atom, the sum or the total of the number of the protons and the neutrons in the nucleus of an atom. And the atomic number, it is the number of protons in the nucleus of an atom. And today we will answer some questions on this point. But firstly, I wanted to give you example before we answer the question. If you have this element, this is called Na. This is called sodium. The atomic number of sodium is 11. And the mass number of sodium is 23. Let's answer any question on this. Number one, the symbol of sodium is Na. The atomic number is 11. The mass number is 23. So if I give you this symbol and I want to calculate number one atomic number. Atomic number equal, this is called the atomic number. The number that is written below the symbol on the left side, this is called the atomic number. So the atomic number of sodium is 11. Another example, another question. I want to calculate the mass number. The mass number equal the mass number that is written above the symbol. So the mass number of the sodium is 23. Number 3, I want to calculate the number of protons. Number of a proton equal the number of a proton equal the atomic number, because the atomic number is the number of a proton. So the number of a proton is 11. The number of electrons in ordinary state or in the stable state of the atom. The number of electron equal to the number of proton equal to the atomic number. So the number of electron is 11. The number of neutron. The number of neutron equal the mass number minus the atomic number. The number of neutron equal the mass number minus atomic number. So the number of neutron equal 23 minus 11 equal 12. This example. So I give you the example of if I give you this symbol. It is the sodium Na 1123. I want to calculate atomic numbers. The atomic number equal 11. This number is atomic number. Mass number is 23. This number is mass number. Number of proton equal atomic number is 11. Number of electron equals the number of proton is 11. And the number of neutrons equal mass number minus atomic number equal 23 minus 11 equal 12. This is example on atomic number and mass number. Let's answer some questions on this point. If the nucleus of an oxygen atom contains 8 protons and 8 neutrons, okay, so the nucleus of an oxygen atom contains 8 protons and 8 neutrons. Find the atomic number and the mass number of oxygen. We want the atomic number and mass number of oxygen, and show the symbol of oxygen element is written. Number 1, if the nucleus of oxygen contains 8 protons and 8 neutrons, calculate the atomic number. The atomic number equal the atomic number equals the number of a proton. Atomic number, what is the meaning of atomic number? The atomic number is the number of protons that are present inside the nucleus. So the number of a proton in this problem is 8. So atomic number is 8. Number 1. This is number 1. Number 2, calculate the mass number. Number 2, mass number. Mass number equal number of a proton plus number of neutron. Mass number equal a number of a proton plus number of neutrons. Why? Because the mass number equal the sum of protons and neutrons. So the mass number equal 8 plus 8. Number of a proton is 8. Number of neutron is 8 equal 16. So the mass number is 16. Number 3, the symbol of oxygen element. You must know that from the table that I said, I talked about it before. The symbol of oxygen is O. And if the letter, if the symbol of the element contain 1 letter, this letter is written in capital. So the symbol of oxygen is O. After this, we calculate the atomic number. The atomic number is 8. And we calculate the mass number. The mass number is 16. So if you write the symbol, you must write its atomic number is 8 and the mass number is 16. The atomic number written below the element at the left side, and the mass number is written above the element at left side. This is the problem number one. Number two, if the nucleus of sodium atom contains 11 protons, okay, and its mass number is 23, find the atomic number and the number of neutrons. Number one, atomic number. Atomic number equal the number of protons. Equal the number of the proton is 11, so atomic number is 11. Number two, number of neutrons. Number of neutrons equal, there is a law to calculate the number of neutrons. The number of neutrons equal mass number minus atomic number. Mass number equal 23 minus atomic number. We calculate it now is 11. So 23 minus 11 equal 12 neutrons. Okay, this is the problem number two. Let's calculate another or answer another question. The opposite figure or this figure represents the structure of the nucleus of fluorine atom. This is the nucleus. Find the number of electrons, atomic number, mass number, the symbol of an atom. Let's translate this figure. This is the nucleus, and there is something that is written is positive 9 and neutral, positive and negative. It is the neutral or not charged 10. What is meant is this? Positive is a proton. So number of protons is 9 because it is positive. Positive and negative, it is the neutrons. So number of neutrons is 10. So from this figure, we can calculate the number of protons. The number of proton is 9. And we can calculate the number of neutrons. The number of neutrons is 10. Let's start to answer this question. Number of electrons. I give you an information, and I talked before. The number of electrons equal the number of a proton in ordinary state. So number of electrons equal the number of a proton equal 9. So number of electrons is 9. Number of electrons equal the number of proton equal 9. Number 2, atomic number. Atomic number, it is the number of a proton. So atomic number is number of a proton. So equal number of proton is 9. So atomic number is 9. Atomic number equal the number of proton equal 9. Number 3, mass number. The mass number, as we know, the mass number, the number of proton plus the number of the neutrons. So it is equal, the number of the proton is 9 and the number of the neutron is 10. So equal 19. So the mass number is 19. The symbol of the atom. The symbol of the atom of fluorine, you must know it. The fluorine is F. And it is the symbol consists of 1 liter. So this liter is written in capital. So we can write it as F in capital. And you must write the atomic number and the mass number. And you calculated it. The mass number you calculate it as 19. And the atomic number we calculated it as 9. So the symbol of fluorine is F, 9 and 19. Atomic number written below the element, the symbol of element, and the mass number is written above the the symbol of element. So, if you want to calculate this problem in as a right, you must translate the figure with plus mean protons plus a negative mean neutrons. So, if you calculate the number of protons and the number of neutrons is in correct way, you can answer this question very easy. Let's answer another example. This is a table, and this table is written in its element symbol: carbon, C carbon 612, sodium, magnesium, chlorine, and argon. See, we will complete this table. The carbon 612 atomic number is 6, mass number is 12, number of proton equal number atomic number is 6, number of electrons is 6, and number of neutrons 6, because mass number minus atomic number. Number 2, sodium 1123 atomic number, it is the number that is written below the symbol, so it is 11. Mass number, the number that is written above, so 23. Number of proton equal atomic number is 11. Number of electrons is 11. Number of neutrons is 12. Magnesium 24. Atomic number is 12. Mass number is 24. Number of proton 12. Number of electron equal number of proton, so it is 12. Number of neutrons is 12. Chlorine 1735. The atomic number is 17. Mass number 35. Because the mass number is the number that is written above the symbol, and the number of proton 17, number of electrons 17, number of neutron equal the mass number 35 minus atomic the mass number minus atomic number is 17, so it is equal 18. Argon 1840, atomic number is 18. The mass number 40, the number of proton 18, number of electron 18, and the number of neutron equals the mass number minus atomic number equal 40 minus 18 equal 22. This is the answer of this table, okay? Comparison between the constituents of the atom, proton, neutron, and electron. Number 1 in position, proton in the nucleus, neutron in the nucleus, but electron revolve around the nucleus in fixed orbit called energy level. Charge, proton is positive, neutral, and the electron is negative. The mass, proton and the neutron, their masses are very large compared with the mass of electrons. So the mass of electrons are very small or negligible compared with protons and the neutrons. Today, we will talk about the movement of electrons around the nucleus. The movement of electrons around the nucleus, like the movement of arms around its center. How? If you turn the fan, if you turn on the fan, firstly you can see the arms, this arms clearly. But after a few seconds or after a time, you can't see these arms clearly. You can see it as a cloud around the center of the fan. After a time, after a time from turning on the fan, you can see these arms, or you can't see these arms, or the movement of the arms clearly. You can see it as a cloud around the center of the fan. A cloud around the center of the fan. You can see it in this way. This form like the movement of electrons around the nucleus. So the electrons are similar to the arms of the fan. Why? Because the arms of the fan turn around the nucleus, turn around the center of the fan at very high speed, and you can't see their places clearly. But the electron and as electrons, the electron revolve around the nucleus at very high speed in some places called energy levels. So electrons are similar to the arms of the fan, where the electrons revolve around the nucleus at very high speed in fixed orbits. These orbits are called energy levels. So this is nucleus, and this is energy levels around the nucleus. This is the nucleus, and this is the energy levels around the nucleus. In these energy levels, there are the electrons. So the electrons revolve around the nucleus in fixed orbits called energy levels at very high speed, and you can't calculate, or you can't know the place of the electrons clearly. So the movement of electrons around the nucleus, like the movement of arms around its center. Why? Because the electrons revolve around the nucleus at very high speed in fixed orbits called energy levels. So what is the meaning of energy levels? The energy level, they are imaginary regions or places not exist in real as a real, but they are imaginary regions or places around the nucleus in which the electrons revolve or move according to their energy. So what's the meaning of energy levels? The energy levels, they are imaginary regions or places around the nucleus, I mean not real, in which the electrons move according to their energy. So what is the maximum number of energy levels? The number of energy levels in heaviest atom is 7. So the number of energy levels in heaviest atom is 7. There are K, L, M, N, O, P, Q. K is first level, L is second, M is third, N is fourth, 5 is O, 6 is P, and 7 is Q. These are the 7 energy levels that or at which the electrons move around the nucleus. So the maximum number of energy level in the heaviest or largest atom is 7. The energy levels are arranged according to from the nearest to the farthest from the nucleus. So the nearest level to the nucleus is K. The farthest level from the nucleus is Q. Each level has a certain amount of energy. I said the electrons revolve inside the energy levels according to their energy. So each level has a certain amount of energy that increased by increasing the distance. So the K is the lowest energy level, Q is the highest energy level, L has energy more than the K and less than the M. So if you increase the distance, you will increase the energy inside the energy level. So the first energy level is K. The K has the least energy. The seventh energy Q has the highest energy level. The energy of level L is greater than the energy of level K and smaller than the energy level of M. Since this is enough today, next session we will talk about the transferring of electrons from one energy level to another. And thank you.